Good morning. We are ready for section 2.4 in AP Calculus, which is the chain rule, which is a very important rule, which you'll see quickly is very, very useful. So look at these four functions. I need it to become clear or be clear how they are different. I would argue that the first three, we already know how to take the derivative. The first one is just take the derivative one term at a time. The second one appears to be a product. We could use the product rule. The third one appears to be a quotient. We could use the quotient rule. The fourth one is the type of function we have not had to take the derivative of yet. It is a composite function. And you need to know that that is, so again, at the moment we're ignoring those first three. We're looking at this one. That is an example of f of g of x. It is a function of a function. I'm gonna refer to these as the inside function and the outside. So I would argue that the inside function in this example is the function x squared minus 7. And the outside function is something to the fourth power. You just have to be able to recognize when something is a composite function. It's not a product. It is not a function times a function. It is a function of a function. And there's the thing called the chain rule that helps us take the derivative of composite functions. And this rule is very powerful. You'll like it a lot. It's easy to use, and you use it a bunch. But you have to remember not to use it if it's a product or if it's a quotient. You have to make sure that it is, in fact, a composite function. So don't learn something new and then forget all the things you once knew. So here's the actual chain rule. You absolutely must know this rule. Here it is. In equation, it says the derivative of f of g of x equals f prime of g of x times g prime of x. You got to be real careful with the notation. And I've seen questions on the AP test where just knowing that formula, the answers come right out. So not only do you have to be able to use it to find a derivative, you have to recognize that that is the formula for the chain rule. The derivative of f of g of x equals f prime of g of x times g prime of x. And now, as far as making sense of what that formula is even telling us, I've highlighted things here, hopefully, helpfully. So the sentence I wrote says the derivative of f of g of x is the outside derivative. The outside function is f. The outside derivative is f prime. So the outside derivative of the inside function unchanged, notice that g of x in purple is just whatever was on the inside originally, not the derivative of that yet. That's the purple. So it's the outside derivative of the inside function unchanged times the derivative of the inside. So that's in blue. That's the derivative of the inside. That's g prime of x. So f prime of g of x times g prime of x. I would argue that should be as automatic to you as product rule. First times the derivative of the second plus second times the derivative of the first. And the quotient rule, which is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Chain rule, outside derivative of the inside function unchanged times the derivative of the inside, or f prime of g of x times g prime of x. So all I've got here is several examples of using the chain rule. And I will tell you right now that the first 1, 2, 3, 4, I guess, are basic chain rules. The function will clearly be a function of a function. And the last three examples are examples that kind of combine the chain rule and the product rule, or the chain rule and the quotient rule, and we'll get to those. So just as you're going through these examples, if the first four start to make sense, which hopefully they do, don't give up on the video, because the last three are different and just as important to go through. So here we go. All right. So y equals x squared plus 1 to the third. And this one I already prepared a little bit. Now, I wouldn't write that down each time, but you absolutely have to be clear that the inside function there is x squared plus 1, and the outside function is something to the third power. So we recognize that as a composite function. So now let's take the derivative. Again, if you need the formula, it was y. Come on, y prime equals f prime of g of x times g prime of x. Okay. So y prime. The outside derivative of the inside unchanged. Well, we need to be comfortable with what that means. The outside function is something to the third power. Well, you've known for weeks now that the derivative of something to the third power is just 3 times that something to the second power. That's just the power rule. So this would be 3 times the inside unchanged, which is x squared plus 1 to the second power. That's a 2. There's the outside derivative of the inside unchanged, and then times the derivative of the inside. And the derivative of the inside, the derivative of x squared plus 1 is just 2x. And that's it now. Do these need to be cleaned up? Oftentimes. And some of the cleaning up gets a little ugly. I'll warn you of that before we get going or before we get to some of the other ones. And there went my lights. Sorry. In this case, all I would clean up is I see a 3 and a 2x, and 3 times 2x is 6x. So I might write this as 6x times x squared plus 1 squared. Done. That's the derivative using the chain rule. It's a real straightforward example of chain rule. Remember, with all of these derivatives, the question might say find the slope of a tangent line or find the equation of a tangent line. Like all those kinds of questions are still fair game. At the moment, we're just learning how to take the derivative of a composite function. So that's a pretty straightforward. I think hopefully it's easy to identify what the inside and outside functions are. Okay, next example I think is very similar. It looks like that. So, and again, I've already identified here what the inside and outside functions are. I won't write that out explicitly in the next examples, but the inside function is 3x minus 2x squared. The outside function is something to the third power. So, just like the last one, the derivative of something to the third power, my outside derivative is still 3 times something squared. So that is still 3 times 3x minus 2x squared. So there's just the outside derivative of the inside unchanged times the derivative of the inside. In this case, the derivative of the inside is what? 3 minus 4x. At that point, I might leave that alone and be done. Depending on the question, sometimes they expand it out, sometimes they don't, sometimes they take out a GCF. So it's, as I've said before, it's often hard to know exactly what form is simplest. If this is part of an extended response question, you just be done. But if there were multiple choice answers, you may have to simplify it. You could multiply that 3 into the 3 minus 4x. You would never FOIL the 3x minus 2x squared with itself. So I'm leaving that like that. So chain rule, inside function, outside function is the derivative of a composite function. The outside derivative of the inside unchanged times the derivative of the inside. Now, let me write what the most common mistake is. If you're going to do this wrong, and I'll cross this out in a minute, you would notice that it's a composite function, and you would notice that the outside function is something to the third power, and you know that the derivative of something to the third power is 3 times e to the second power, and you would write this. And I'm going to quickly, I'm not done talking about it yet, but I'm going to quickly cross it out. I want to convince you what went on there, convince you how tempting it is. So the outside function was something to the third power. And so, okay, I knew 3 times that something squared, but that's something in the middle. What did I do? I took the derivative of the inside in the middle there. That's not where that goes. So if I go back to my original picture here, then what's important here is the stuff here in purple. It's the outside derivative of the inside function unchanged, which I didn't do in that last example. So I'm just telling you that's a real common mistake with the chain rule. It's the outside derivative of the inside. Don't change the inside until the end. At the end, multiply by the derivative of the inside. Okay, I've got a few more here. Let's look at this one. Actually, I just thought of one I'm going to add to the list here because we're having too much fun. So let's take the derivative of this. So first, you might want to rewrite this. You should always be writing roots as exponents. Now, I'm going to do this in two steps. You can maybe do it in one. I can write this as x squared minus 1 squared to the 1/3. That's just a cube root becoming to the 1/3. And then I have a raising a power to a power, which is just multiplying exponents. So I would argue my actual function is x squared minus 1 to the 2/3. I have not taken the derivative yet. I just rewrote this as in a form that I can. So now I have an inside function. It is x squared minus 1. I have an outside function, which is something to the 2/3 power. So you have to recognize that as a composite function. And I am going to take the derivative of that, the outside derivative. So the outside function is something to the 2/3 power. So my derivative is going to be 2/3 times this something. Now I need to lower the exponent by 1. And 2/3 minus 1, I believe, is negative 1/3. You got to be real careful with just subtracting 1 from an exponent. And then you're not done. Then it's times the derivative of the inside. And the inside is x squared minus 1. And the derivative of x squared minus 1, I believe, is just 2x. And now, again, as far as how you might clean that up, it's pretty common to not leave things with negative exponents. And also, if the original problem had roots in it, your answer is probably going to have roots in it also. So I can see a couple things I could do here. I see a 2/3 and a 2x. I think that becomes 4x there. That's just 2 times 2x. And I've got a 3 there. And now that x squared minus 1 to the negative 1/3, since it's a negative exponent, I can move to the bottom. So I might do this. All right, to the positive 1/3. And then since I said now that would be a completely valid place to stop. But since my original problem had it written as a root and not an exponent, I might write it as 3 times the cube root of x squared minus 1. Make sure there's no typos there anywhere. So I think that's probably the form you'd see it in. But again, chain rule. It is the derivative of a composite function. Okay. This one kind of looks like a quotient, but you may recall we did the quotient rule. If back then I said, hey, if one of the parts of the quotient just a number, it might be easier to not quotient rule it. So I would argue that this one, while we could quotient rule it, it's going to be easier to rewrite this as negative 7 times 2t minus 3 to the negative second. I would argue it's going to be easier. I didn't take the derivative yet, just rewrote it. Now I've got an inside function, 2t minus 3. I've got an outside function, something to the negative second power. The constant out front's not going to bother me any. I'm just going to multiply it through by the derivative. So now let's take the derivative of this. The derivative of something to the negative second power. Well, that's just negative 2 times that something to the negative third power. Remember, lowering the exponent by 1. Negative 2 times negative 7 is 14. And then I don't change the inside. I lower the exponent by 1. But now the chain rule says I have to multiply that by the derivative of the inside. The derivative of 2t minus 3 is just 2. And now how might this look? 14 times 2 is 28. And I might move this to the bottom since it's a negative exponent as 2t minus 3 to the third power. I think there's my derivative. So another fairly simple chain rule. We'll use the quotient rule in a moment here. But that one, if one of the parts of the fraction is just a number, it's easier to rewrite it and not have to use the quotient rule. Okay, I need to add one that I forgot about. We need to talk about trig functions because trig functions are weird. So I'm going to write 2 examples here. Y equals the sine of x squared. And the other one is y equals sine squared of x. You need to know that those are different. And this notation on the right is how you're supposed to write that, sine squared of x. But I actually don't like that notation. You need to know that when you write sine squared of x, and you saw that when you did trig identities, sine squared of x plus cosine squared of x equals 1. Like you've used that notation before. You have to know that when you use that notation, that is actually saying this. That's the sine of x squared. That's what that means. And that's important because Now the red function and the blue function have different inside functions and outside functions. And these I am going to write down. For this one, we'll do the blue one first. My inside is just, that's a colon, is just x squared. And my outside is the sine of something. Let's take the derivative of that. That's absolutely a composite function, so I need a chain rule. The outside derivative of the inside unchanged. What's the derivative of the sine of something? You know that is the cosine. So here, y prime would be, that's a prime, would be the cosine of the inside unchanged, which is x squared, and then times the derivative of the inside. The derivative of x squared is 2x. Now let's be careful cleaning this up. You can't combine that x squared and that 2x because you're cosining the x squared and not the 2x. So it would not be the cosine of 2x cubed. It would just be 2x cosine of x squared. There's that chain rule example. Now let's look at the other one. Get my picture out of the way. So here, let's identify, here my inside function is in fact the sine of x, and my outside function is something squared. So you have to be real careful with trig functions that you clearly identify what's inside and what's outside. All right, and now let's use the chain rule. So the derivative using the chain rule is the outside derivative. My outside function is something squared, and the derivative of something squared is 2 times that something to the first power. So this is 2 times that something is what? Sine of x. Now, it's to the first power. I'm not going to write to the 1, but I could, but it's unnecessary. And then times the derivative of the inside. The derivative of the sine of x is the cosine of x. And I think I'm done. I don't think that one cleans up any. So just be real careful with trig functions that you're being aware and clear on what the inside function is, what the outside function is. Okay. Tell you what, I'm actually going to stop there because the next 3 are long enough that I'm just going to make a different video probably later today. So there'll be a short assignment based on this. And again, what I said at the beginning of these last 3 examples, which I will just show you real quick. Oh, no, not like that. This example, you'll notice, is a product, but one of the 2 pieces, that second piece, is its own little composite function. So it's a product rule, but there's a composite function inside the product rule. This one is a quotient rule, but again, that bottom, when you take the derivative of the bottom, it's its own little chain rule. So again, we'll have to combine the quotient rule and the chain rule for that one. And the last one, notice a couple things. There's a quotient, but the whole thing is to the second power. So really, you wouldn't want to start using the quotient rule because the entire function is not a quotient. The entire function is an inside function and an outside function. So that's a chain rule. Along the way, when you take the derivative of the inside, you have to use the quotient rule. So those last 3 examples involve combining the product rule and the chain rule, or the quotient rule and the chain rule. And I will save that just to give this in smaller increments. I will save that for the last time. So since I just didn't decide not to do that right now, I'm not going to show you the assignment, but I will write it obviously at the top of the instructions when I post this on Classroom. So that is it for kind of your introduction to the chain rule. So have a great Thursday.